So we have two presenters today. We have Michelle McKee from the Corec Group, and we have Zita Karki from Malin Technology. And they are going to, thank you very much for coming, ladies, and we're very much looking forward to hearing what you have to say. The ladies are going to start off presenting themselves. So that makes my job very easy. So I'm just going to hand it over to Michelle, first of all. Would you like to share your presentation, Michelle, and we'll get going?
Great, thank you very much, Jenny. Just bear with me one moment until I share my screen. Okay, so can you see the presentation there? I'm going to put it into full screen mode if that has displayed correctly for you guys.
Yeah, perfect.
It has. Okay, thank you very much. So Michelle McKee is my name. I'm the Geospatial Business Area Manager for Corec. So the topic of my presentation today is mobile mapping, a solution for industry to measure, map and manage infrastructure remotely. So just to give you a little bit of a background on myself, I graduated from NUI Maynooth with a BA Honours in Geography. Then went travelling for a couple of years, then came back and completed an MSc in Environmental Resource Management in GIS. While I was in employment, I then added to the kind of CV with the diploma in GIS from what was DIT, but now the Technological University of Dublin. And then I completed a diploma in geology and geosciences then from the Open University as well. So in terms of career history, my first career job was with Westmeath County Council as a GIS technician in the planning department. When that short-term contract finished, I moved over to Bord Gáis, which is now Gas Networks Ireland, and again was a GIS specialist there. In 2008, I moved to a company called CCS Surveying, and this allowed me to kind of dabble in land surveying initially, where I worked on various projects collecting data on site and then creating the GIS deliverables. Throughout that particular role, I worked on loads of projects in land surveying for the OPW, for various roads departments, and did a lot of work in Northern Ireland Water for NI Water and the like. Then 2013, moved back closer to home and took a job with Bord na Móna as their surveyor and GIS specialist for their upcoming wind projects. Then in 2014, I joined Corec, where I stayed to the present day, and it's been a great role, which has allowed me to work with clients from all areas of geospatial, including GIS, land surveying, engineering, construction, ecology, archaeology, and kind of everything in between. So just a little bit about Corec. Our mission statement is to empower you to measure, map and manage the natural and built environment. So when companies are operating in the natural and built environment, success demands accuracy, safety and speed while reducing costs and environmental impact. So we believe that embracing geospatial solutions will transform your outcomes and deliver that success. So I suppose just a little bit about my role. Everyone's jobs comprises lots of various things, but I suppose the overarching themes are to develop in-depth knowledge of cutting-edge surveying and mapping technology provided by a number of manufacturers, and just identify new and existing clients who would benefit from these technologies, and then to support these businesses and organisations as they adopt the new technologies. Also within this role, I work with specialist teams within Corec, such as the K Services Division and the K-Matic team. And both of these teams will be central to the case study, which we're going to look at now in a moment. So the case study I've chosen for today's presentation is the UK Concrete Roads Programme. So we do have a lot of similar projects here in Ireland, but with many projects, we might be in the middle of the project, or customers may not want to kind of share outcomes just yet, or they may want to kind of keep some of the technology and developments in-house, whereas National Highways have kindly let us share the kind of history of this project and their outcomes and the different technologies that they used. So the UK Concrete Roads Programme, we'll go through a little bit of the objectives, history, the solutions that were used, the method of survey, which is mobile mapping, how we used AI for road defect detection, and the outcome and benefits. and then further innovation and applications with this technology. So this project was carried out on behalf of National Highways. There were a number of other consultants involved, such as AECOM and Matt MacDonald. Ourselves and Corec were involved on the survey and analysis side of things, and then our sister company, K-Matic, provided the software and data management system and the AI learning for the project also. So a little bit of a background on the project itself. National Highways manages England's motorways network, and about 4% of their network is consisting of concrete roads. They were coming towards the end of life. There was 400 million pounds set aside to manage and maintain, carry out repairs on these roads up to 2025. And a key thing for National Highways was to try and identify life extension schemes and reconstruction schemes. There was a huge area of roads that needed to be mapped, managed, analysed. And the main objective of the programme was to identify innovative new methods that can reduce both the cost of the works and the impact of construction on road users and communities. So I suppose a further difficulty with this is the difficulties in surveying information on these roads. You know, they're dangerous carriageways, huge volumes of traffic, and then for reconstruction and maintenance crews to go back out at night time to locate these defects and problem areas in poor visibility conditions, often, you know, due to various factors, works could not be completed, whereby, you know, maybe defects couldn't be located, they couldn't be accessed and things like that. So there was a huge amount of money lost through works that could not be completed or abandoned before they were finished. So National Highways then undertook an evaluation of all of their digital technology to look at the various aspects of the road's life cycle, from the construction of the roads to repair to operation and to maintenance of the network. So they wanted a way to increase the productivity of the roads, increase the productivity of the crews. They wanted to improve safety for both their repair crews and for other road users. They wanted to reduce the disruption to road users when they were carrying out these maintenance and repairs. They wanted staff to be able to make better decisions, and they wanted to lower their carbon footprint. So again, what was identified was the need for a golden thread to link everything together, or the digital twin, as we like to call it these days, and for that to be used throughout the life cycle of the project. So surveying tends to be used to be a very manual process, with crews actually needing to be on the ground to carry out their surveys. Again, on busy roadways, this would, you know, require traffic management, would require roads to be closed. So we were looking at ways to automate this process and to capture information remotely. So in comes the mobile mapping system. So mobile mapping system was developed whereby we can install this unit on a vehicle, and the vehicle will drive the roads and carriageways at normal driving speed, thus reducing the need for people to actually be on the road network. Again, you know, it captures information, point cloud information, and really high quality imagery. You know, then when this information was captured, the information is not easily managed, I suppose, for many organisations, as traditionally you would have needed specialist software to view the point cloud information and to work with them. So, you know, many of these softwares would have been quite expensive, so it would have limited the amount of people that would have had licenses for this. It also might have required some specialist training, which again isn't practical for all of the people who would like to be able to use this information. So in came the Clearview 360 platform. So this was a platform developed by our sister company, K-Matic, who developed web-based portals to allow you to store large volumes of information. So this meant that immediately, you know, you had a place to host this information, and it wasn't stored on National Highways network or servers. and a large number of people could access the information when they needed it, as only your web login was required. So this allowed people to work remotely, to be based all over the UK, and to be able to work with the same data sets all of the time. So from there, all of the stakeholders could access and use this information to make better decisions in terms of managing the road network. Defects then could be obtained with very precise location data and can be fed back then to repair crews out on site, so that they can navigate to them within a centimetre of the actual location. This meant that the repair crews now had less abandoned works, and equally when the repair crews carried out defects, they could send the information live from the field back up to the Clearview 360 platform, and straight away any of our project managers or technicians could see what works have been carried out and what works were left to be done. So a little bit more in the mobile mapping system. On the top of the unit there, you can see the 360-degree ladybug camera. So this takes images in 360 directions. There's also cameras mounted on the side of the unit, which will capture information maybe lower down in the carriageway at an angle. And then there's a further camera, which is pointed down at the road surface of all times. So that captures really high quality information on the surface of the road. So then on the side of the unit, you can see there's two dual laser scanners, which spin at 500 scans per second, and they will take in approximately 1.6 million points per second each. So you're talking about every second that the scanner is working, it's capturing about 3.6 million points of information. So this is why the unit can be mounted on a vehicle and driven at usual road speeds. So then when you have captured this point cloud information, you can do a number of things with it. So the first view there on the top left, this is what the point cloud information looks like when you overlay it with images captured by the device. We refer to this as the colorized point cloud. Then underneath there, you can see that you have the point cloud, but it's classified into different colors. So we have quite clever routines in the software that will allow you to put all of the point cloud information, let's say from the surface of the road on one layer, then from the vegetation on another layer, from structures on another layer, etc. Then up on the right hand side, you can see some of the information then from the different cameras. So the one on the top there is the ladybug camera. The one down on the left will be the kind of side view cameras. And then in the middle, there's a down-facing camera that identifies the defects on the road. So when this information then is looked at in various different softwares, you can see the graphic on the left will show you the point cloud of capturing the survey of the road. But you can overlay that with different things like the design drawing that the consultants may be working with. There on the right-hand side, you can run routines as well that will analyze the surface of the road in detail. So what you're seeing there on the right-hand side is areas where there's a variation in the road level surface. It's probably hard to see, but just on the little graph below, it kind of can give you a cross-section view of the level of the road. Then what does the information look like in the portal? So this will be the standard view in the portal, which allows the different stakeholders then to identify different areas which have been surveyed. So for anyone from a GIS background, this looks very familiar with your ability to switch on and off different layers, to have existing data sets from previous surveys available to be able to overlay on your new surveys. So again, you can delve deeper into the captured information. On the top screen there in the middle, you can see a plan view of the captured information with the ability to click into any of the images that are taken and to be able to pan around in 360 degrees to see exactly the carriageway at that particular point. So that will be similar maybe to our Google Maps views, but actually it goes a little bit further because of there is a point cloud behind the information. You have very high accuracy locational data, and from there you can actually start taking measurements. So you can see there, the user there has taken measurements of the carriageway. It can essentially survey the road remotely. So instead of having to carry out your survey out on site and pick out all of these defects on site, someone who is sitting at their laptop, hundreds or thousands of kilometers away, can actually carry out the road survey. So again, that's just kind of showing you some of the different types of information that can be overlaid in the portal. So then, once defects are identified, they can be drawn up in the portal, and all of these kind of data sets can then be exported, and the location of the defects then sent to the field repair crews. So for many previous projects, we would have done all of this kind of manually, where you had a person that would sit down and go through hundreds and thousands of kilometers of road data. It was quite a laborious task, so it required a huge amount of manpower hours. So wouldn't it be great if this could be done automatically? So that just gives you an example there of various defects, let's say, that the end user would see as they pan through the photography, and then how they would kind of draft them up within the K-Matic program. So again, you have you can identify areas on polygons, etc. So to bring our solution on from this, we kind of moved from manual survey to automated survey methods by using the mobile mapping system. But again, this manual analysis was the thing now that was, eating up everyone's time and could, delay the project significantly. So again, we needed to find some way of automating this analysis. And with the developments in machine learning, this suddenly allowed us to do this in great ways. So with our K-Matic team, we have some in-house AI machine learning specialists, and they were able to create an AI tool to actually automate this whole defect analysis. So the AI can be applied to many different types of data. The AI could look at the imagery, it could look at the point clouds, it can use shape and spatial data, and it could also use tabular data. So the first part in the process was looking at our existing data set and doing some labeling of the data to identify the different defects in this case that we wanted the algorithm to look for. The next part of it then was training the model, which my colleagues in the K-Matic department looked after. Unfortunately, I have no background in this myself. After a number of weeks or months, the AI model would have ran through a number of benchmarking processes to ensure that the model was identifying defects correctly and up to satisfactory standards. And then once they were happy, the model was deployed within the portal to start carrying out these automatic defect detection. So with AI, by using AI, we were getting centimeter accurate analysis of the road surface. And AI can work with any geolocated surface imagery. It doesn't require advanced hardware. It also didn't require us to send our information to anyone, to share our information with anyone. All of this can be done locally within your own project. And the huge benefit to us was that AI can process a kilometre of roadway in 60 seconds. So just looking at the imagery here, these would have been defects that the AI tool actually identified and highlighted, and all of this was done so quickly once the model was well established. So the outcome and benefits of this project was that it reduced boots on the ground for traditional surveys and inspections. So it allowed us to create digital twins of the roads that can be used by people remotely. So it reduced the cost of works. It also minimised the impact of construction on road users and local communities, which is a huge cost saving to the entire economy, and reduced the risk to workers on site by being able to survey the roads remotely. There was a significant reduction in the carbon footprint, and it also improved data accessibility and quality within national highways. We now could have numerous stakeholders able to access the information very easily via the web portal. The cost saving to national highways, they calculated, was 12.9 million on that particular project. So well worth the investment in developing these new technologies. In terms of innovation and applications, these kind of solutions are already used in Ireland for fibre, utilities, rail, gully and canopy. There's many people out there that are already using their own bespoke machine learning technology. And what we're looking to do is to empower people with next generation solutions that unlock the potential of geospatial data. And so, really with this, there's no limit to where it can go in future. And hopefully we'll have some nice projects we can present on later in the year as well. That's it from me.
Great. Thank you very much, Michelle. That was terrific. And you answered my question, which was whether or not AI could help with your analysis. It looks like it's done very effectively.
Yeah. Any other questions from anyone in the audience? Well, if anyone thinks of anything, at any stage during the rest of the presentation, you can send them on to me at the end. Thank you.